Okay, in number 9 on the Unit 5 review, it says that we are given that the cosine is 7/25 and the sine of theta is negative. So we know that our cosine is positive and our sine is negative. This happens in quadrant 4. So we could possibly set up a triangle, and our cosine is 7/25. This is a triple 7, 24, 25. Again, if you don't know that, you can always use the Pythagorean theorem. And you'll get that b is 24. Okay, we know that it is negative because our y here is negative in quadrant 4. So we have to find the sine of 2 theta. We're going to use our identity, which is 2 times the sine of theta times the cosine of theta. The sine of theta is negative 24/25. The cosine was given to us as 7/25, or we could look at our triangle. Our adjacent side would be 7, our hypotenuse would be 25. Okay, so we go through and we solve this, we get negative 336 over a positive 625. The cosine of 2 theta, you could choose any of the 3 identities that you want to use to solve. I'm going to use 2 times the cosine squared of theta minus 1. You could use cosine squared minus sine squared. You could use 1 minus 2 times the sine squared. I'm just using the cosine, or the one that only uses the cosine because I was given the cosine. And what happens if I accidentally solved for this opposite side incorrectly? Okay, so we get 2 times 49 over 625. You would need a common denominator. So I'm going to change 1 to 625. Of course, if you're using your calculator, that would not matter. And we get negative 527 over 625. Okay. Number 10. Number 10, we're going to be solving for the sine of theta and the cosine of theta. But what we're told is that theta is between negative 3 pi over 2, so not negative 3 pi over 2, positive 3 pi over 2 and 2 pi. This means that theta is in quadrant 4, which means that our sine of theta will be negative and our cosine of theta will be positive because of our awesome stag trig class. Okay, so the cosine is positive, the sine is negative. I'm going to fill that in so I don't make a mistake on theta in the end. So now the cosine of 2 theta is 1/8. I'm going to go ahead and solve for my sine first, just because it's listed first. There's no reason why we have to solve for it first. So that would come from 1 minus the sine squared, 1 minus 2 times the sine squared of theta. I know that the cosine of 2 theta is 1/8. We subtract 1/8, or we subtract 1 from 1/8, and we get negative 7/8 equals negative 2 times the sine squared of theta. We divide both sides by negative 2 or multiply by a negative 1/2. We get positive 7/16. Then we take the square root. Technically it's plus or minus because it's the square root of our variable theta, but we know that we're going to choose the negative because theta is in quadrant 4. So we get negative root 7 over 4. At this point, you have so many ways that you could find the cosine. We can reuse the cosine of 2 theta, and that would be either using one of 2 identities. It would either be cosine squared minus the sine squared, or you could do 2 times the cosine squared minus 1. You could do sine squared plus cosine squared equals 1. You could even set up a triangle at this point. Doesn't really matter your method of solving. You don't need that parenthesis there. So I'm going to add 1 to both sides. We get 9/8 equals 2 times the cosine squared. We divide by 2 or times by a positive 1/2. We get 9 over 16. Oops, I got rid of my 2. Then we take the square root of both sides. Again, we are taking the square root of our variable theta, so technically it's plus minus. We're in quadrant 4 though, so we know we're going to choose the positive. So we get the cosine of theta is 3/4. The square root of 9 is 3, the square root of 16 is 4. Okay. The rest of these problems go through verifications. So remember, you want to choose the side that you think you can do more with, which is usually the side that's a little bit busier. Okay, and this one, I don't know. It doesn't really matter in this one which side you choose to rewrite. So I'm going to kind of look at it. This one I know I can use the double angle identity and write this as 2 times the sine times the cosine. This one, I'm thinking that we can factor out 2 and end up with 1 minus the cosine squared. I actually think this one could go both ways and it would be fine. I will take this side and make it my goal. But again, in this one, I think both ways would be fine. So the only thing right now that I know that I could do is I could change my sine into 2 times the sine times the cosine. Then at this point, I'm thinking I have to go with the tip of changing things into sine times the cosine. Now it looks like I have a cosine in the denominator, a cosine in the numerator, they cancel. So now I have 2 times the sine squared, because sine times sine is sine squared. Alright, so somehow I have to get to here. I'm going to backtrack. So previously I said, well, we could factor out a 2. And what would that do? One minus the cosine squared and a sine squared, I think we're done. Because if we have sine squared plus the cosine squared equals 1, if I subtract a cosine squared, we get that the sine squared of theta equals 1 minus the cosine squared of theta. So sine squared equals 1 minus the cosine squared of theta. If we were to distribute the 2, we reach our goal. So in this one I worked backwards a little bit, but again, it doesn't make a difference if we even started with this one, factored out the 2 first, then try to bring in our sine. However, then we would probably have to look at this and start writing out our identity.
At this time, the lockdown is over. Once again,
in number 12,
the lockdown is over. Thank you for your cooperation.
It definitely clearly looks like this side, the right side, is our busier side. So I'm actually going to make this side my goal. Okay, so now it's probably more difficult to take this and convert it into some fractions here. What I do notice immediately is that I have a trig function squared and a plus 1. Or even just a 1 and a trig function squared. 1 minus the tangent squared isn't an identity. However, I do know that 1 plus the tangent squared is a Pythagorean identity and it's equivalent to the secant squared. What I'm going to do is bring my secant into my numerator. I'm going to change that into, well, actually I'll backtrack a step here. because most of you write it out as 1 over the cosine squared and then multiply by the cosine squared. We can distribute the cosine. Okay, then when we do that, it looks like we're going to have to convert our tangent into the sine squared over the cosine squared. These cancel, and I have the cosine squared minus the sine squared. At this point, there are a few ways that you can write out your final answer. If you recognize these two, I know that the cosine squared minus the sine squared equals something. And that something is that this is the double angle identity for the cosine. And then I also know that a double angle identity for the cosine is 2 cosine squared of theta minus 1. You actually don't even really need this step. You can substitute in the sine squared and make this 1 minus the cosine squared, distribute the negative, and then get to this. It's a little bit longer.